In today's video, you will learn how to verify if two triangles are congruent. We will start with the concept of congruence in geometric figures and proceed to triangle congruence. We will tackle on what conditions would make two triangles congruent. You will also gain an understanding of the different methods of verifying if two triangles are congruent. Toward the end, I will walk you through in answering sample problems on triangle congruence to check your understanding of the concept, to let you experience how to apply what you've learned, and to let you go through the process of how problems related to this are analyzed and solved, so that you will be able to successfully solve geometry problems similar to this in the future. If your lesson is on congruence in triangles, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who's interested in learning math, then this video is for you. What does congruent mean? Congruent means to have the same shape and size. Each pair of figures are congruent for they have the same shape and size. Congruent figures are a result of a flip, a turn, or a slide. Here, one triangle is a result of a slide of the other. Thus, we say that the two triangles are congruent. When two figures are congruent, we can lay one on top of the other and they would match up exactly. The sides that match up are the corresponding sides, and the angles that match up are the corresponding angles. The corresponding sides of two congruent triangles are congruent, and the corresponding angles are also congruent. Congruent sides have equal lengths, and congruent angles have equal measures. When two triangles are congruent, the corresponding angles and sides are marked this way. The sides with one tick mark or hash mark are equal in length. The same with sides with two tick marks and the sides with three tick marks. In like manner, the angles with one arc are of equal size. The same with the angles with two arcs and angles with three arcs. If the congruent triangles are a result of rotation or reflection, they may not appear in the same position, but the corresponding sides and corresponding angles are there, as in this case here. You just have to look for them. Once you have found them, you may need to mark them like this so you can easily see which part is equal in size to which. From here, we can write this congruent statement. Triangle ABC is congruent to triangle QRS. Because the triangles are congruent, the corresponding parts are also congruent. Hence, we can also write the following statements. On the corresponding side, side AB is congruent to side QR, side BC is congruent to side RS, and side CA is congruent to side SQ. On the corresponding angles, angle A is congruent to angle Q, angle B is congruent to angle R, and angle C is congruent to angle S. Recall that the order of the letters in the names of the congruent figures displays the corresponding relationships. So, even if there is no diagram, you would know that angle A is congruent to angle Q, angle B is congruent to angle R, etc. Likewise, side AB is congruent to side QR, and so on, because they have the same positions in each triangle's name. Though it is a fact that when two triangles are congruent, the corresponding sides of the congruent triangles are congruent, and the corresponding angles are also congruent, you do not have to show that all these 6 pairs are congruent to prove that the triangles are congruent. there are certain ordered combinations of the sides and the angles that would be enough to prove that the triangles are congruent. Let us learn all of them. The first one, SSS, or side, side, side. That is, if three sides of a triangle are congruent to three sides of another triangle, then the two triangles are congruent. The second, SAS, or side angle side. That is, if two sides and an included angle of one triangle are congruent to two sides and an included angle of another triangle, then the two triangles are congruent. The included angle here refers to the angle formed by the two sides of the triangle being used. Third, ASA, angle side angle. If two angles and an included side of one triangle are congruent to two angles and an included side of another triangle, then the two triangles are congruent. The included side here refers to the side between the two angles being used. Fourth, AAS, or angle side. If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. The non-included side here refers to either of the two sides that are not between the angles being used. Now, the fifth one has something to do with a right triangle. Remember that the sum of the measures of the three angles in a triangle is 180 degrees, no matter what type of triangle it is. Now, let us look at the right triangle here. This type of triangle has one angle with a measure of exactly 90 degrees, whereas the measure of the other two angles has a sum of 90 degrees. Its sides are given these names: hypotenuse, the longest side, and the legs, the other two sides. After knowing its characteristics, I think we can now proceed with our proof of triangle congruence. As I said earlier, this next one has something to do with a right triangle. So the fifth one is HL, hypotenuse leg. That is, if the hypotenuse and one leg of one right triangle are congruent to the hypotenuse and one leg of another right triangle, then the right triangles are congruent. Remember this, learners, you can only use this if the triangles are right triangles. How do you know that you have right triangles? Look for this marking, the box, indicating a 90-degree angle measure on one of the angles of the triangle. Or the right angle might not be marked on the triangle, but it is stated on the problem. Thus, you have to read the problem carefully. In such a case, mark your angle on the drawing immediately. Okay, so these five are referred to as the triangle congruence postulate or the triangle congruence theorems. Okay, let us look at these triangles, learners. These triangles are congruent because two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle. In short, AAS, right? How many pairs of angles were used in proving that the triangles are congruent? Right, 2 pairs. How many pairs of angles do we have on these two triangles? There are 3 pairs, right? Now, what can you say about the third pair of angles on these two triangles? You are right, the other pair not used in proving that the two triangles are congruent is also congruent. In like manner, only one pair of sides is used in proving that the two triangles are congruent of the three pairs that are there. So, what can you say about the other two pairs of sides? You are right, they are also congruent. So, once the two triangles are proven congruent using any of the 5 postulates or theorems, then the other corresponding parts of the triangles that were not used are also congruent. An acronym CPCTZ is usually used to refer to this. Let us do the sample problems that follow to check our understanding of the concepts and to know what strategy to use in solving the problem. Here's the problem. Sample problem 1. Consider the figure below. Explain how the two triangles are congruent. So a figure is given. Options are here. A. The triangles are congruent by SSS. B. The triangles are congruent by SAS. C. The triangles are congruent by ASA. And D. The triangles are congruent by AAS. Okay, so we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are we looking for here, learners? You are right. We're looking for the option that would correctly explain how the two triangles shown on the drawing are congruent. What are we given here, learners? We're given an illustration or drawing with markings on some of the angles. Now, we examine carefully the illustration. How many triangles do you see here, learners? Right, there are 2 triangles. How will you describe the 2 triangles? Okay, the 2 triangles are drawn such that one side is shared by the 2. Can we draw the triangles separately? Yes, of course. So how many sides are actually there? You are correct. There are actually 2 sides. Okay, we will look at the original drawing this time, but we know at the back of our mind that there are 2 sides there, though we just see one side, okay? Now, what can you say about the lengths of these shared sides? You are correct. They are equal in length. Now, since they're equal, we can mark these sides, right? Okay, let us do it. Can you now tell me what part of the upper triangle are marked? What are marked are the 25-degree angle, the shared side, and then another angle having a measure of 75 degrees. How about the other triangle? Do you see the same thing? On the other triangle, the following are marked: the 25-degree angle, the shared side, and another angle having a measure of 75 degrees. Can you tell us what these markings on the 2 triangles suggest? You are correct. The markings suggest that the 2 triangles are congruent by ASA. Okay, so which option is this? Which one is our answer? Is it option A? Option B? Option C or option D? There you are, learners. The answer is option C. Wow, that was easy. Okay, let us do sample problem 2 this time. Consider the figure below. Which triangle congruence theorem can be used to prove that the 2 triangles are congruent? Option A, SSS. B, SAS. Option C, SSA. D, ASA. EAAS, option F, AAA, and option G, HL. Again, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are we looking for, her learners? You are right. We are to choose from the options which congruence theorem can be used to prove that the two triangles are congruent. What are we given here? A figure is given with markings on some sides and some angles. Okay, so we're given a drawing. We have to study it carefully. What are marked on this triangle? Okay, what are marked are side, another side, and an angle on each triangle. Looks like an SSA combination. Do we have such combination on the postulates that we have studied earlier? Okay, so there is none. The reason why we do not have such combination is it cannot guarantee that the shapes of the triangles formed will always be the same. You have to remember this, learners. There is no such combination as SSA or ASS for triangle congruence, okay? From that, we have narrowed down our choices. Option C is out. Okay, are the triangles right triangles? Not. We do not see any markings or indication that the triangles have right angles. So, option G is also out because HL is for right triangles only. Now look at the drawing again. There are two lines that intersect, right? Remember that any two intersecting lines form vertically opposite angles that are congruent. On our intersecting lines here, this is one pair of opposite angles, and they are equal in size. This is the other pair, and these two are equal in size as well. Let us go back to our drawing again and mark the angles that are congruent. Let's do it. Now, do you recognize any combination of angles and sides that are on our list of postulates that we can use to prove that the two triangles are congruent? Okay, so we have SAS. What else? We have ASA. Any other? There is AAS. Now, let us look at the options that we have here. So, what are our answers? There you are, learners. Our answers are B, D, and E. Learners, do you understand why options A and F could not be answers? For option A, take note that only two sides are marked. So option A is not an answer for SSS means that three pairs of sides must be marked, or we say three pairs of corresponding sides must be congruent. For option F, which is AAA, it is not a combination that would give congruent triangles. That's why it is not on the list for triangle congruence. Look at these, learners. The corresponding angles on both triangles are the same in size, but the two triangles are not of the same size. One is larger than the other. That is why we do not have this combination in triangle congruence. AAA does not guarantee that the two triangles will always be congruent. Remember that for two triangles or any two figures for that matter, the figure must have the same shape and the same size for them to be congruent. There you are, learners. We are done with this problem. Let us move on to sample problem 3. Here's the problem. In triangle ANH and triangle FDC, side AN is congruent to side FD, and angle M is congruent to angle D. Which statement correctly proves that the two triangles are congruent? Option A, if side NH is congruent to side DC, then triangle ANH is congruent to triangle FDC by AAS postulate. Option B, if side NH is congruent to side DC, then triangle ANH is congruent to triangle FDC by SSS postulate. Option C, if angle H is congruent to angle C, then triangle ANH is congruent to triangle FDC by AAS postulate. And option D, if angle H is congruent to angle C, then triangle ANH is congruent to triangle FDC by SSS postulate. Again, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, her learners? You are right. We are to choose from the options which statement correctly proves that the two triangles are congruent. What are we given here? We're given drawings of triangle ANH and triangle FDC with these congruent statements. Side AN is congruent to side FD, and angle M is congruent to angle D. These given information are also indicated on the illustration. Now let us examine the drawing and the options carefully. The drawing shows only two parts of its triangles are marked. Remember that the postulates call for at least 3 parts of each triangle being marked, right? The options, on the other hand, offer statements that might fill in the missing part that would correctly prove that the two triangles are congruent. So our strategy here is to look at each option and add the information given on the option by marking our triangles and see if it will give a combination of angles and sides that would prove that the triangles are congruent. Let's go. Let us look at option A. If side NH is congruent to side DC, then triangle ANH is congruent to triangle FDC by AAS postulate. Let us add this information into the drawing and see what will happen. There you are. What combination of angles and sides do we have now? You are correct. It is SAS. So in this case, the triangles will be congruent with that added information by SAS postulate, not AAS postulate as stated on the option. So option A is not an answer. Let us move on to option B. If side NH is congruent to side DC, then triangle ANH is congruent to triangle FDC by SSS postulate. Okay, so the same information as in option A is to be added. So we will just use the drawing we had earlier. Early on, we mentioned that the markings in both triangles display an SAS postulate. Option B is saying that it is an SSS postulate. So, option B is not an answer. Okay, so we move on to option C. If angle H is congruent to angle C, then triangle ANH is congruent to triangle FDC by AAS postulate. Again, we add this information into our original drawing and see what will happen. There you are, learners. Here is our new diagram. What postulate is displayed here? Okay, so with this added information, the triangles will be congruent by AAS. Is this option C? Okay, so yes, option C is a correct answer. Now we will examine option D. If angle H is congruent to angle C, then triangle ANH is congruent to triangle FDC by SSS postulate. The same added information is given here as in option C. And we saw that with that added information, the triangles will be congruent by AAS postulate and not SSS. So, option D is not an answer. Okay, so what is our answer again? There you are. It is option C. We are done with this problem. It was easy, right? Okay, so we move on this time to our last sample problem. Sample problem 4. Here's the problem. Consider the two triangles below. Which statement describes the additional information needed to prove that RL equals 12? Option A, if angle A is congruent to angle R, then triangle ANG is congruent to triangle RJL because of SSS postulate, and therefore RL equals 12 because corresponding sides of congruent triangles are congruent. Option B, if angle A is congruent to angle R, then triangle ANG is congruent to triangle RJL because of SAS postulate, and therefore RL equals 12 because corresponding sides of congruent triangles are congruent. Option C, if angle N is congruent to angle J, then triangle ANG is congruent to triangle RJL because of SSS postulate, and therefore RL equals 12 because corresponding sides of congruent triangles are congruent. And option D, if angle N is congruent to angle J, then triangle ANG is congruent to triangle RJL because of SAS postulate, and therefore RL equals 12 because corresponding sides of congruent triangles are congruent. Okay, as usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? You're right. We are to choose from the options which statement describes the additional information needed to prove that RL is 12. What are we given here? We're given a drawing of the two triangles with side lengths. Okay, so the problem calls first for a proof that the two triangles are congruent. Then once we have proven that they are congruent, we can now say that the other corresponding parts not used in the proof are also congruent. In short, CPCTC, if you recall. For this problem, after proving that the two triangles are congruent, we can say that the measures of the corresponding side not used in the proof are the same. So our strategy is to examine its option, put the added information into our given drawing, then check if the added information will prove that the triangles are congruent. If proven congruent, then conclude that side RL is also 12. Let's go. We will first modify the drawing by putting tick marks on the corresponding sides that are congruent as given. With this modified drawing, we can now start working on each option. Let us look at option A. If angle A is congruent to angle R, then triangle ANG is congruent to triangle RJL because of SSS postulate, and therefore RL equals 12 because corresponding sides of congruent triangles are congruent. We will add this information into our drawing like this. Now, let us examine the drawing and see if we have an SSS postulate displayed on it. Learners, we do not see an SSS postulate on our drawing. Only 2 pairs of sides are marked here, not 3 pairs. The added information is on angles, not sides. Therefore, the additional information does not prove that the triangles are congruent, so we cannot conclude that RL is 12. Let us move on to the next option, option B. If angle A is congruent to angle R, then triangle ANG is congruent to triangle RJL because of SAS postulate, and therefore RL equals 12 because corresponding sides of congruent triangles are congruent. Okay, so we have the same added information as that of option A. What is displayed after adding that information is not an SAS postulate. In an SAS, the angle is an included angle, which is not what we have here. The angle added is a non-included angle. Therefore, the additional information does not prove that the triangles are congruent, so we cannot conclude that RL is 12. Let us move on to option C. If angle N is congruent to angle J, then triangle ANG is congruent to triangle RJL because of SSS postulate, and therefore RL equals 12 because corresponding sides of congruent triangles are congruent. Let us add the information into our modified drawing. With this added information, do we see a display of SSS postulate on it? The added information is a pair of angles, not a pair of sides. So, no, the additional information does not prove that the triangles are congruent, so we cannot conclude that RL is 12. Let us move on to option D. If angle N is congruent to angle J, then triangle ANG is congruent to triangle RJL because of SAS postulate, and therefore RL is 12 because corresponding sides of congruent triangles are congruent. Now we have the same added information here as that of option C, which is angle N is congruent to angle J. So we will use the same drawing. Let us examine again the drawing. Do we see a display of side angle side postulate on our drawing? Where is the added information again on our drawing? Look, the angle is right between the two sides, an included angle. So the SAS postulate is clearly displayed here. We can then say that the two triangles are congruent by SAS postulate, and therefore RL is 12 because corresponding sides of congruent triangles are congruent. So our answer is option D. There you are, learners. That was easy. I hope you acquired a lot of learnings on this video. There you are, learners. Let us summarize what we have learned in today's video. We have learned that, first, congruent means to have the same shape and size. So, two figures are congruent if they have the same shape and size. Second, congruent figures are a result of a flip, a turn, or a slide. Third, when two figures are congruent, the corresponding parts are also congruent, which means that the corresponding sides have the same lengths and the corresponding angles have the same measures. Fourth, when two triangles are congruent, the corresponding sides can be marked with the same number of tick marks, and the corresponding angles with the same number of arcs. Fifth, triangle congruence postulates or theorems are the ordered combination of the sides and the angles of the triangles that would prove that the triangles are congruent. These are A. SSS, B. SAS, C. ASA, D. AAS, and E. HL. Sixth, CPCTC means that once the two triangles are proven congruent using any of the 5 triangle congruence postulate or theorems, then the other corresponding parts of the triangles that were not used are also congruent. 7. When solving a problem, you must read it and may read it several times when needed to know what you are looking for, what information are given, and to figure out how the information can help solve the problem. 8th, when a figure is given, make use of it and modify when needed. It is there to help you analyze the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.